According to the National Electrical Code, all metallic piping systems that are likely to become energized must be electrically bonded together. This bonding creates a continuous path for fault currents. In the scenario described, copper piping is connected to plastic underground water lines. This connection forms a metallic piping system. Therefore, the copper piping needs to be bonded at every location where it connects to the plastic piping. This bonding practice is crucial for safety. It ensures that in the event of an electrical fault, such as a lightning strike or an electrical surge, the fault current can safely flow through the bonded piping system and back to the electrical service panel. The National Electrical Code defines a system as a group of metallic piping components that are interconnected and are likely to become energized. In this specific situation, the copper piping that is connected to the plastic water lines is considered a system under this definition. Because of this classification, bonding at each connection point is a code requirement. Electrical bonding is the process of connecting metallic parts of a building's electrical system together to create a low impedance path for fault current. This path helps to ensure that circuit breakers or fuses will trip quickly in the event of a fault, which can prevent electrical shock and fire hazards. There are several methods that can be used to bond metallic piping systems. One common method is to use bonding jumpers. Bonding jumpers are short lengths of copper wire that are connected to the metallic piping and to a grounding electrode conductor. The grounding electrode conductor is a wire that connects the building's electrical system to the earth. The size of the bonding jumpers and the grounding electrode conductor must be sized according to the National Electrical Code. Another method that can be used to bond metallic piping systems is to use bonding clamps. Bonding clamps are devices that are clamped onto the metallic piping and connected to a grounding electrode conductor. Bonding clamps are available in a variety of sizes and materials. They should be selected based on the size and material of the piping being bonded. When bonding metallic piping systems, it is important to make sure that all connections are clean and tight. Loose connections can create high impedance paths which can prevent fault currents from flowing properly. It is also important to protect the bonding connections from corrosion. Corrosion can also create high impedance paths. The National Electrical Code provides detailed requirements for bonding metallic piping systems. It is important to consult the National Electrical Code before performing any electrical work. Ignoring these requirements can lead to dangerous situations. Firstly, identify all metallic piping systems in the building. This includes water pipes, gas pipes, and any other metallic pipes that could become energized. Secondly, determine the size of the bonding jumpers and grounding electrode conductor. The size of these conductors will depend on the size of the electrical service and the type of piping being bonded. Consult the National Electrical Code for specific sizing requirements. Thirdly, install bonding jumpers between all metallic piping systems. The bonding jumpers should be sized according to the National Electrical Code and should be installed in a way that provides a lower impedance path for fault current. Fourthly, connect the grounding electrode conductor to the building's grounding electrode system. The grounding electrode system should consist of a ground rod, a ground plate, or other approved grounding electrode. Fifthly, inspect all bonding connections to ensure that they are clean and tight. Loose connections can create high impedance paths, which can prevent fault currents from flowing properly. Sixthly, protect all bonding connections from corrosion. Corrosion can also create high impedance paths. Seventhly, test the bonding system to ensure that it is working properly. The bonding system can be tested using a low resistance ohmmeter. The resistance between any 2 points on the metallic piping system should not exceed 1 ohm. In addition to the general requirements for bonding metallic piping systems, there are also some specific requirements for bonding water piping systems. The National Electrical Code requires that water piping systems be bonded to the building's grounding electrode system at the point where the water service enters the building. The National Electrical Code also requires that water piping systems be bonded to all electrical equipment that is likely to become energized. This includes water heaters, pumps, and other electrical appliances. The National Electrical Code provides detailed requirements for bonding water piping systems. It is important to consult the National Electrical Code before performing any electrical work on a water piping system. When dealing with copper piping connected to plastic water lines, the transition point becomes a critical area for bonding. Because the plastic is non-conductive, it interrupts the continuity of the metallic piping system. Therefore, the copper section must be independently bonded to ensure that it is properly grounded. This is typically achieved by connecting a bonding jumper from the copper pipe to a nearby grounding point, such as a metallic water pipe that is already part of the grounding system, or to a grounding electrode conductor. The size of the bonding jumper is determined by the size of the service entrance conductors, as specified in Table 250.66 of the National Electrical Code. The bonding jumper must be securely fastened to the copper pipe using a listed bonding clamp or other approved method. It is also essential to protect the bonding connection from corrosion, especially in damp or humid environments. This can be achieved by using corrosion-resistant materials for the bonding clamp and jumper, or by applying a protective coating to the connection. Regular inspections of the bonding connections are recommended to ensure that they remain in good condition and that the bonding system continues to function properly. If any signs of corrosion or damage are detected, the connection should be repaired or replaced immediately. It is also important to ensure that all electrical work is performed by qualified and licensed electricians who are familiar with the requirements of the National Electrical Code and local electrical codes. These professionals have the knowledge and experience to properly design, install, and maintain electrical systems, including bonding and grounding systems, to ensure the safety of the building and its occupants. The importance of bonding copper piping at every location where it connects to plastic piping cannot be overstated. It is a critical safety measure that helps to prevent electrical shock and fire hazards. By following the requirements of the National Electrical Code and consulting with qualified professionals, you can ensure that your building's electrical system is properly bonded and grounded, providing a safe and reliable electrical environment. The National Electrical Code specifies that the size of the bonding jumper for metallic water piping must not be smaller than the size given in Table 250.102 of the National Electrical Code, based on the size of the service entrance conductors. This table provides the minimum size of the bonding jumper based on the size of the largest ungrounded service entrance conductor or equivalent area for parallel conductors. For example, if the service entrance conductors are 2/0 American wire gauge copper, the minimum size of the bonding jumper would be 8 American wire gauge copper. If the service entrance conductors are larger, the bonding jumper would need to be larger as well. It is important to consult the National Electrical Code Table 250.102 to determine the correct size of the bonding jumper for your specific installation. In addition to sizing the bonding jumper correctly, it is also important to install it properly. The bonding jumper must be securely connected to the copper piping and to the grounding electrode conductor. The connection must be made using a listed bonding clamp or other approved method. The bonding clamp must be installed in a location that is accessible for inspection and maintenance. It is also important to protect the bonding connection from corrosion. Corrosion can increase the resistance of the connection and reduce its effectiveness. The connection can be protected from corrosion by using a corrosion-resistant bonding clamp or by coating the connection with a corrosion-inhibiting compound. The National Electrical Code also requires that the metallic water piping system be bonded to the equipment grounding conductor of the electrical equipment that it serves. This is to ensure that the equipment is properly grounded and that any fault current will flow back to the source, tripping the circuit breaker or fuse. The equipment grounding conductor must be sized according to the National Electrical Code Table 250.122, based on the rating of the overcurrent protective device protecting the circuit. For example, if the circuit is protected by a 20 amp circuit breaker, the minimum size of the equipment grounding conductor would be 12 American wire gauge copper. If the circuit is protected by a larger circuit breaker, the equipment grounding conductor would need to be larger as well. It is important to consult the National Electrical Code Table 250.122 to determine the correct size of the equipment grounding conductor for your specific installation. The equipment grounding conductor must be connected to the metallic water piping system at a point that is as close as possible to the equipment that it serves. The connection must be made using a listed bonding clamp or other approved method. The bonding clamp must be installed in a location that is accessible for inspection and maintenance. It is also important to protect the bonding connection from corrosion. In summary, bonding copper piping connected to plastic water lines is a critical safety requirement that must be followed to prevent electrical shock and fire hazards. The bonding jumper must be sized correctly, installed properly, and protected from corrosion. The metallic water piping system must also be bonded to the equipment grounding conductor of the electrical equipment that it serves. By following these requirements, you can ensure that your electrical system is safe and reliable. Always consult with a qualified electrician to ensure compliance with all applicable codes and regulations. This is not a substitute for professional advice.